Donc pour cette deuxième partie d'événement, on va plutôt discuter de l'Allergologie Challenge et notamment des résultats. Comme vous l'ont les intervenants de la première partie, c'était un data challenge qui est quand même très challengeant avec des sujets d'actualité sur les données de santé environnement. Et donc, comme les lauréats de ce data challenge vont nous présenter leurs résultats, on va switcher en anglais. Donc de la même manière, si vous avez besoin, il y a des casques de traduction qui sont disponibles à l'accueil. So for the second part of the event, we are pleased to welcome the winners of the Allergen Chip Challenge. So we'll start by welcoming Mitil Salunke, the third prize winner of the Allergen Chip Challenge. So Mitil is passionate in data science and is now a student in the International Baccalaureate Diploma Program.
And I would like to begin with my solution as the third place solution for the allergen chip challenge. I'd like to have 4 sections in my solution. The first one is data processing. Then the second one is finding the best models and hyperparameters, and the post-processing. And then I would like to have my opinions on the data challenge. So I'll get started with my data processing. So the data sets in the raw format was not usable, as you could not put it directly in the model that I used. So there was 3 steps that I took to make sure the data set was usable and I could extract the best performance out of it in the data set. So the first one was the removal of the label 9, which represented the unlabeled patients, and inclusion of this label. I think in the middle of the challenge, we dropped it from the test data set. And so I tried to use this data in various formats. So the first one being was I just used a multi-label output for this, like predicting it but then not predicting it in the test data set. That didn't work out. So then the other approach I tried to use this was just training the model on the 0 and 1 data, and then after labeling the data from the model, but this also degraded the performance of model. So in the end, I just dropped the columns which had label 9 as the data set. Then the second important part was the splitting of the data into validation and train. But since data is really valuable in this field and the data set was really small, I don't want to lose any data because it was going into validation. So there's a technique called as stratified k-folds. And since this was a multi-label data set, I had to use something called as multi-label stratified k-folds. So basically what this does is like it has the same validation, it has the same split. Which means, like, let us say the target 1 contains 80% positive and 20% negative samples. The multi-label stratified k-fold tries to keep this balance same. So no model in each fold has, like, let us say, skewing or more weightage to a more weightage for some label just because it has a different fold. So this technique ensures that the validation labels stay the same. And this also allows me to use the whole data set as validation, which makes sure that my cross-validation and my leaderboard scores stay same, which was really important to make sure I did not shake down. Like I had a 9th position in the public leaderboard, but in the private leaderboard, I was able to go to the 3rd place because I did not overfit to the public leaderboard. And the third part was filling the NaN values, which means the columns that did not have any values in them. This was a major challenge because I had to try a lot of things to make sure that my model does not overfit to these NaN values. So I tried a lot of things for it. So the first thing I tried was something really complex. I tried to use skitlearn, which is a library for data science. I used something called as an iterative imputer. What this does is it's a really complex thing. It takes each feature in the row and tries to be a machine learning model itself. So like how we predict the target, but instead we are predicting the feature here. This was really time consuming, but it had to be something that I had to try. but sadly it did not work out. Then I went on to try to fill the data set with just zeros, but that did not also work out. So in the end, I just used the simple thing of filling it with the mean values of each column. That was the best thing. I tried filling with the mean of the row itself, but the filling with the mean of the column was better. Now I'll go on to my feature engineering part, where I created some features myself. So there were 5 features that I created, really simple features that improved the performance of the model a little bit. These weren't the main part of my solutions, but regardless, they were good to have. So the first one was really simple, row mean, just the average of the row as a metadata column, and then the standard deviation in mean STD. Reflecting the spread of the data, and then I multiplied the product of the rows mean and the standard deviation. This was something that I really have no idea why it worked, but it just worked. Also, so I would had the multiplication, like I multiplied all the rows, all the columns of each row together. So this helped in the model to know if there are 0 values in the data, because if there was a 0 value, the product would also be 0. And then the row sum of the metadatas in the row. Really simple feature engineering, but it did work. Then there was my model. I tried XGBoost, as we have been discussing about it a lot. So there's a tweet from Bojong Tungiz, who's like a grandmaster on Kaggle, which says XGBoost is all you need. Which is a bit true, and I definitely agree with him. There were a lot of different gradient boosting methods and also traditional methods such as cat boost, light GBM, random forest. I also tried deep learning methods such as simple linear models, and I also tried a CNN because there were images in the data too. So I tried a CNN called as ResNet 50. Sadly, I was not able to experiment much with the images because of the resource constraint, and it takes a really long time to train with images. So I just dropped the idea of using images and went on with just the tabular data. Then I also tried ensembles, but I was not able to make them work, partially because I was really out of time by the time I was able to perfect my single model score and come to the part of ensembles. Because of this, I just ended up relying on the 15 folds. So these 15 folds were the amount of validation and training. So the data had 15 different sets of validation, and this ended up with a 15-fold XGBoost model. And since this was a multi-label, multi-target data set, I employed something sklearn has known as multi-output classifier. Which basically makes it much more easier for me to be able to do multi-label and also multi-target. What this does is basically really simple. It creates 20, since there are 29 binary target, it creates 29 XGBoost model for each of the targets. So each target has one model, and this is all very simply wrapped behind multi-output classifier, which makes it much easier and much more readable for me to do a mundane work. So that was the main model of my solution. And then coming to hyperparameters. So there were 3 hyperparameters that I tuned. The number of estimators I set it to 950 after a lot of trial and error. So what n estimator basically does is it's the amount of time the model goes over the data. Then there's the learning rate, which I set it to 0.06 after also trial and error. This basically is like how much does a model learn at every step. If this is too high, the model gets stuck in between its slope and doesn't really learn. But if it's too small, it will also get stuck. So this was the best learning rate to prevent overfitting. And then co-sample by tree. So this is a hyperparameter which basically says that I set it to 0.5, that each tree, so like each epoch, the model only receives 50% of the features. This helps a bit because it makes sure that the model does not rely on just one feature and forgets to learn from the other features. Helps make it more robust since there were NaN values and you couldn't simply rely on one feature, and helps promote model robustness and overfitting. So then I come to the main part of my solution, which is post-processing. Post-processing was the most important part of my solution. As you can see from the results before, post-processing, the average F1 score was 0.5, but after setting thresholds, after doing post-processing, my score was 0.775. So I'll talk about what post-processing I did. So the main post-processing I did was setting the thresholds. So since this is a binary label problem, the model here is outputting a probability, let us say 0.99, 0.11, but the predictions that were demanded from us were zeros and one. So this gave me an opportunity to set a threshold. So since what it basically does, it corrects the model's mistake of over predicting. So what I did, it was really simple to find the threshold. I just set up a loop and I defined a range. So I have the range here from 0.0001 to 0.9999, and basically it traces from like each increment of 0.001 till this range to identify the best threshold. And this threshold is found out for each of the targets. So for example, target 1 would have a different threshold, since the model will have different predictions for each of the thresholds. And you can see from the results that before setting it was 0.5, and after setting the F1 score was 0.775. And I also have an interesting observation that I saw here. It's a scatter plot that shows that as the number of positive sample increases, there needs to be a higher amount of threshold for the model to achieve the best macro F1 score. And you can see the correlation of a Pearson correlation of 0.95, which shows there's a really strong correlation between number of positive samples and the threshold. Now I would like to go on to something that I use as an interpretability mechanism, something known as SHAP values, which basically stands for Shapley additive explanation. This is something that is used to understand what features are we relying on the models for. So I picked 2 of the targets here, since showing all of them would not be feasible. So if you want to see the SHAP values for all of the targets, you can go onto the repository and you can go onto my notebook in the 3rd place private leaderboard section. So I have 2 of these. So what these charts basically represent is how important was each feature in the prediction of each model. So the calculation process for this is for each feature, the model prediction is computed with and without the feature, and then the difference between the prediction with and without feature is calculated for each combination. Then they are weighted and it's calculated how important is each feature by the difference. So you can see treatment of rhinitis is an important feature, as you can see from the graph. There's a lot of yellow, and the same for respiratory allergy. Treatment of asthma is something that I saw over multiple targets was an important feature. And there were a lot of features that were not important. As you could see, these features, they were something that were just there. So the model did rely on, let us say, you could see there were some features that it should not rely on, let us say, French region. That is something but it did rely on because of the biases in the data sets. And this is something that can be further explored to see that such biases do not occur again. And there's also some things that I wanted to try, but I could not because of lack of time. So an ensemble of multiple seeds for XGBoost. So by seed is basically the random value the model starts with. So multiple seeds, by having multiple seeds, you can improve the robustness. But since training each model took me around 2 hours, I did not have the time to try out multiple seeds. And this was something I thought of later in the competition. But if I could try this, I think it would improve the robustness of the model and further improve it in the ensemble. Then the images, this was really pretty interesting when I started the competition. I actually focused on the images and I tried a CNN. My first model actually was not just a tabular one, but it was actually a combination of just images. So what I did was I took a CNN and I fed it an image. And the features outputted by the CNN were all merged with the linear layer. So like all the features were merged. So like a ResNet 50 model is a convolutional neural network. It will extract the features in the shape of 384. And then I added all the other features. And these were merged together and fed into a linear layer. This was I tried a ResNet 50 and EfficientNet. Both of these actually showed really poor performance. And because of the lack of time and resources I did not explore. And I think if I had more time or resources, I definitely think that the images could be much more beneficial and improve the performance of the model. Since the thing with CNNs is that you don't have to hard code each, like you don't have to do the feature engineering for the CNNs to get the best performance. And more feature engineering, since this was really my first actual tabular competition that I did seriously. Most of my competitions before this were just images or NLP or natural language processing. Didn't really have the best knowledge for what features are the best and how do you do the best feature engineering. And that's why I think because of the experience I've gotten from this competition, next time I can do better feature engineering. So that's all of my solution. And thank you to the SFA and the trustee team for such an interesting competition. It was really invaluable, the experience I gained. I would also like to thank Julian for all the help for me being actually able to present here. Thank you to him. And now I am open to the questions, if any of you have it.
So we have a question here.
Merci. Thank you very much, Mithil. It was really great to listen to how you managed to take this challenge. I think that there are very interesting pieces of information that you gave us. For example, when you say that there is a bias in the French regions and the French department, in fact, it's not. In fact, you are just, finding and putting your finger on something which is not only relevant for allergists, but should also be relevant for public health policies, because France climate is different between north and south. Southern France has nothing to do with northern France. So it's your data show with a mathematical background that there is a difference between such regions and that it should be addressed. Another comment that I would like to make is that in your model, if I understood correctly, because I'm not a data scientist and I'm a physician, you took a probability of 0.5 for all parameters to be present or absent, something like that.
Yeah. So basically,
but you shouldn't, because in fact, it's not general. I mean, even in general population, it's not like gender. It's not like half percent. I mean, 50% of people are allergic or sensitized and 50% are not. You have a smaller percentage of people who are sensitized and an even smaller percentage among these ones who are allergic. So in fact, that 0.5, I think if you change it, you could even improve your algorithm.
Okay, so coming to the 0.5, so the thing is, I think I should explain it a bit more. So the 0.5 thing was the features I took, and this was only during the training. During the inference, where the predictions are actually given, the models actually filled all the data, all the features, and during only the training. So there's something we called as, let us say I would take something from image recognition, where we use data augmentation. Let us say if there's a picture of a cat, you actually flip the cat and you change the colors, but this isn't something that's useful to us humans. But if you read research papers about image recognition, this is something that is very important for. I would like to take the example of AlexNet, which was like the first convolutional neural network, and that was one of the main solutions which led it to winning the ImageNet competition, was data augmentation. So like something that's good for humans, we can't like flipping it, but this actually gives the model new perspective. Same for this, since not all the like I mentioned, not all of the features were completed. There were some NaN values. So the model relying on these features alone could not give it the better perspective for these features. So this was only during the training and helped it not to overfit. Like just, okay, this is this and okay, so it improved the performance. Like I did try it out. So co-sample by tree was something that is not set in XGBoost by default. It's 0.1 by default. And this is something I found later on, and this actually did improve my performance in the both my cross-validation and the public leaderboard.
Oui, juste. Just one very very small comment. When you said that you needed to push the thresholds up for in people who had a lot of sensitization data, in fact, you discovered by your own means and by yourself and with mathematic means the definition of atopy, which is the fact that some people are genetically predisposed to making for a lot of IgEs, and it's like a positive feedback. And in clinics, when we see that people have a lot of IgEs, we naturally increase the threshold in our head to say this one is relevant, clinically relevant.
Yeah, that's
so
one
congratulations.
of the. Thank you. That's also a really beautiful thing about data science, because I don't really have a background in health, and even remotely, I don't even have biology as a subject in high school right now. But I'm still able to make contributions to health because of how easy it is for me to just get the data and use my mathematical skills to like find out things that would not be possible for, like I say, somebody like me before without this.
Joanna, I think I would like just to make a follow-up comment on what you said. I don't think he used the 0.5 as the main threshold for all the feature. I think he used specific threshold for every single label.
So congratulations for your dynamic presentation. I understand very well why you are so you have so much passion for that domain of computer science, because it seems to be so much challenging and fun at the same time. So fantastic. My first question is, when you did the pruning of the data set, removing all rows with a 9, what percentage of the data set did you remove at that time?
I think it was around, I'm not at this since this was a bit long time ago. I think I think around 50% or 40% of the data was unlabeled. Yeah.
Less than 30%.
Okay. So
yeah.
1/3. Okay. And other question: do you think it would have been helpful if you have known the relationships between allergens in terms of cross-reactivity or pathophysiological importance?
Can you please repeat it? I didn't hear.
Come on. Okay. Do you think it would have been helpful and improved your results if you have known during your study the relationship between allergens? Some are very close to each other, so people frequently are sensitized with IgE against a whole family of allergens, and also some allergens have more significancy in terms of pathophysiology. Some are more important than others. Do you think it would have been helpful for you to improve your?
Yeah, I think that would have helped me improve the performance because if you see from my feature engineering, it was really basic. There was nothing really specific for allergology that I did in my feature engineering. So something, if I had the knowledge of that, I would have definitely implemented in creating new features from the data set. But okay. I obviously didn't have the knowledge.
So, yeah, okay. So people need to be both computer scientists and biologists. That would be fantastic. So are you going to start some studies, medical studies now? Or no, you have time.
No, because I don't only do health competitions, I do many more. So like doing in-depth domain knowledge for each of the competitions, that would not be practical. So it's better, I think computer science skills in general would help me much better than having like domain knowledge for a specific.
Do we have other questions here? We don't have any question online. So thank you again, Mithil. We are really glad you came in France. And congratulations. So for the next talk, we are going to welcome Ning Jiang, the second prize winner of the Allergen Chip Challenge. So Ning is principal data scientist from Acerta. He's specialized in artificial intelligence application for the manufacturing industry. Can you hear us?
All right.
Yeah.
All right. So can you hear me?
Yeah.
Yeah, okay. Yeah, let me.
Go ahead. But we can't see you.
Yeah, I'm just turn on the
Okay.
camera. Yeah. Okay. Seems good, Yeah. First I should share my screen. You can see my screen, right? Yes. Yeah, okay. Right. It should be there, right?
Yeah, but can you put it on
Okay.
full screen?
Yeah. Okay. All right. Hello, everybody.
Perfect.
I'm Ning.
Thank you.
Yeah, I'm from Canada, actually. I'm in the morning here, so but I know in French it's afternoon, so good afternoon. I am a principal data scientist from Acerta, so yeah, the company is doing some like apply AI to the manufacturing industry. But I'm glad I joined this competition, so now I'm going to talk about my solution. I'll try to make it simple. Yeah. So first of all, this is some challenges I think we have in this competition. First of all, it's a multi-label classification problem. We all know we have like 29 labels for each patient. So it's not simple binary, right? So second one is actually there are strong associations between those labels, or we call it targets. This is some example, like if you have severe allergy is true, then the allergy presented must be true. Yeah, that's easy to understand. And also, if any type of the food allergy exists, I mean the subtype, like food to fish, allergy to fish, then the food allergy and allergy presented must be true. There's also some other strong association, like I don't know what it's short for, but this type of allergy is true, then the other type is very likely to be true, something like that. Uh, next point is we are using F1 score metric for this competition. I believe this is, I'll say there's some downside choosing this metric. First of all, we need to do hard predictions. Basically, we need to say yes or no. We cannot output any uncertainties to this prediction. In other way, we have to pick a threshold by our own. It's not by the application or by the customer. This is not ideal, I believe, in some circumstances. So maybe we need something other metrics can measure the uncertainty as well. The next one is I believe this metric also treat all the target equally. So we like to take the mean of all the 29 targets. So actually this is also now can be improved, let's say this, because some targets like the general allergy is very easy, relatively easy, but some other target is kind of like because it's very unbalanced, you rarely have those patients. So to predict those target is actually very challenging. But now you treat each target equally. So maybe the end solution just because it's working well for those rare cases, and then overall it did good for the other part, but that's still not good. So basically, we need to think they shouldn't be treated equally. In other words. So there's some challenge I found, and what I did also I'm going to follow some steps like pre-processing and those modeling, and the last to the post-processing. So I cleaned it like there's some outlier or something wrong there, say like in the treatment columns, because of the way it is like you use a comma to separate all the treatment, but there's something like you put a point like a numerical value. So I fix this and cut all the categorical columns as pandas category type. And I fix some targets actually also. The most nice are useless because we don't know what the real thing are. But there's some things like this. When allergy present is zero, so you don't have any allergy, then you shouldn't have any subtype like respiratory allergy or food allergy. But for some cases, it's somehow a null, so we can easily transfer those null to 0 because this null shouldn't be there, should be there in this case. So some data pre-processing. Next is model training. So I train separate model for each allergy target. So transfer one multi-label classification problem to multiple binary classification. Actually, I tried to use it like a multi-output classifier, doing like multi-label, but it just cannot compete the performance with the separate multiple binary classifiers. Okay, and for the algorithm, use a tree-based algorithm because it's typically good for those small tabular data set. Here, like GBM and the cat boost is used, and this stratified k-fold also use cross-validation. I believe I only use 5 folds. The loss function is AUC because it generally work well for binary classification. And yes, and for the feature engineer side, I did light feature engineering because I'm not expert in this domain. So I try to use light feature, something like how number of zeros you have. I believe the test set is the signals from blood test. So how to really do the combine them, I have no idea. So I just do some simple like how many total zero you have, something like that. I think the previous third winner also present some features, something like that. And next, I automatic feature selection. There's a pipeline I run, so I can select which feature for each target. So basically, for each target or for each model, we have a fine-tuned or optimized feature set for that target. So after the training, okay, this is just showing one benefit of doing separate binary classifier. The third winner also mentioned this. So it's like the sharp analysis. You can see this is one result for this target. It's a allergy to fish. This is an allergy to some certain respiratory thing. And you can see apparently there are different allergies. For this fish, some most important features are skin symptoms, age, and French residence department, and some other blood test result. But apparently for this one, you can see the location factors plays an important role here, like French resident department, rural or urban area, French region. So what I mean here is if you can fine-tune each model on each target, we can extract different insight regarding that allergy. So that's one benefit of doing that. Of course, it increases the complexity of the whole solution because we have like 29 separate models. You can think this way. Okay, after the modeling, do some post-processing to actually to win the competition because you have to fine-tune something after the model. And one is in sample models, I took weighted average prediction from the like GBM and the cat boost algorithm. So use both basically. A high weight on like GBM. I remember it's like 80, and this cat boost is 20%. And also we need to optimize for F1 score because this is the metric we are using. So we pick the best threshold that maximum F1 score based on the out of sample predictions. Something similar to the previous presenter's solution. Yeah, we have to fine tune the threshold. And also last one, I also override some predictions because we learned some association rules. I learned from explorative data analysis. I also ran association rule mining algorithm. So this is some new rules. So something like this. If this allergy is true, suppose after we do the prediction and I optimize for the F1, we found for one patient, this is true, then severe allergy must be true. It's very likely. I remember the confidence like 95 or even higher. So in that case, I will override severe allergy is true, no matter what the model output is. So that's something I done after I did for the post-processing. I believe that says everything regarding my solution. So I'm open. Thank you very much. So I'm open to questions. I guess I will stop sharing. Yeah. Thank you.
Thank you again, and congratulations. So do we have question here on site?
Thank you very much. My name is Joanna Witt. I don't know if you see me, whatever. Anyway, so I have a general question, because when we compared and evaluated your results for the challenge, we saw that all the competitors that we analyzed had a lot of false positive results, meaning you almost never find negative diagnostics. Everybody is sensitized, everybody is allergic. How do you have an explanation for such a false positive, such a high rate of false positive diagnostics?
First of all, I don't think we have a very high false positive rate, because F1 score at the end of the day is very close to 80. So the precision, because F1 kind of balance the precision and the recall. So for that case, you can think roughly like the precision is close to 80, roughly, okay, not exactly. In that case, the false positive rate shouldn't be very high, I believe. And in any circumstance, you can see, you always can find some false positives. Why? Because something like the label could be wrong. That's one reason. You never know, because the label it could be wrong, because the data is from real data set. It is actually it's true, but you label like false, so we found it's false halting. Another reason is we still don't have enough sample to simulate such false positive. So for the model perspective, there is no way for the model to learn how to detect such positives. That's my short answer. Does that answer your question?
Thank you. Yes, it answers my question, and it also gives us, I would say, it sheds light on our general reasoning. Thank you.
Thank you.
Anyone else?
Thanks, Ning. So just a quick question: was there a reason that you did not use the image that has been provided? Is it just because of the computational resources, or like design decision?
I think two reasons. One is the image data is not the majority, because most, I believe, I remember quickly take a look at that. Most most patients don't have such image, I believe. It's like less than half. So that's one reason. The other reason is, once you take the image approach, it's going to be a totally different thing. And also it requires more resources. I mean, the computer resources and also time perspective. So that's why I did take that approach. I didn't try, yes.
Thank you. Anyone else had a question? I don't think we have question online. So thank you again, Ning Jin, and congratulations.
Thank you, everybody.
So we are going to continue with the first prize winner. So I would like to welcome Rakesh Jarvupula, who graduated from NIT Schiller Electrical Engineering. So he is dedicated to leveraging data science competitions as a potent means to address real worldwide problems, particularly those with significant impact on public health. Can you hear us? We can see your screen, so that's great.
Can you hear me?
Hi. Thank you for being available today. So you can go ahead if you're ready.
Yeah. Hello, everyone. I'm Rakesh Jarpala, and today I'm going to walk you through my solution for the allergen chip challenge. And before diving into the details of it, let me take a moment to thank the organizers and everyone who is being part of this project for a very long time, and to my fellow participants who pushed me to work hard and find real insights from the data to make an impact on the public health. So just give me a minute. Yeah. So I'll be speaking more as the organizer introduced me. I'm going to start with the solution summary, and then I'll briefly discuss about the feature engineering and selection techniques which worked well. And then after, I'll briefly talk about the modeling, where I used different models to predict the final output. And then I'll share what I think are most important findings from the challenge and can help the organizers for further development of the project. And then I'll close my presentation by asking a few questions if you have. Bit about myself, I am mostly freelance data scientist, and I work on real world problems through data science competitions. And quickly about the solution which I presented, it was a simple ensemble of tree-based models, especially the XGBoost, LightGPM, and CatBoost. And for final prediction, I did the post-processing as the previous winners suggested, like tuning the threshold for predicting whether the patient has certain type of allergy or not. And I created a simple allergy to source and root map so that I can aggregate different allergen proteins to create new features relevant to the task at hand. And in this competition, I would say like feature engineering is the key, and that helped me a lot for the during the inference time. Speaking about the feature engineering, I aggregated different proteins based on their source, and I mean how they are available in the environment and how they enter human body. Based on that, I aggregated different allergen proteins by computing their mean and minimum, maximum, what is the maximum for that source and that root type, certain features like that. And there are features that I created using treatment type, whether the patient has gone certain type of treatment and how many treatment does he or she has taken. And there are some rule-based features like missing value counts, zero counts, and basic statistical values like mean of the row, median, and sum of the rows. These were a few features that I created. And for the training of the model, I used only data sets which are relevant to the task at hand. For example, if I wanted to predict whether the patient has respiratory allergy or not, I would basically use metadata about the patient along with the allergen proteins which are relevant to the respiratory. That would result in a very light model along with the fast computation. I mean, you don't need vast majority of resources for training that model. Basically, we are using less data and we will be getting more accurate model with that less data. And some irrelevant allergen proteins were dropped and some outliers were treated using second highest value. I mean, they are replaced with the second highest value. Talking about a simple example, which in which we predict whether the allergy present or not. If you take the important features which model things are important, like you can see, like there are many features which are I created using different protein values, basically aggregating them. And as you can see, these performed well, and they help the model well better predict whether the patient has allergy or not. Coming to the modeling part, basically what I did was I trained three different models and taken their probability values and computed mean for each target. And for each target value, I tuned different threshold to make a prediction, whether threshold in the sense the model will use that value to decide whether a particular patient has a particular type of allergy or not. And this is the basic ensemble that I used for the final solution. And to be specific, like I trained different model for different target types, because like presence of one allergy may not be indicative of presence of another type of allergy. Let's say respiratory allergy presence is entirely different from food allergy type presence. So I trained different model for each target. And from the experiment I did a chain classifier, which is like a chain of classifier which trains on predictions from the previous classifier. So it's like a chain of models. It didn't perform well. That's why I trained a different model for each of the target values. And if you see if you look at the data, there are many target values with less positive records. I mean, the data set is very imbalanced. To address the issue, I basically taken two methods into account. One is scale positive weights, where the model weights differently while training on different targets to account for the imbalance in the data. And another thing is to tune the threshold that I spoke earlier to make the decision about presence of certain type of allergy or not. And I used a repeated stratified k-fold. I mean, the model will repeat the process of training over 5 times, and the whole process will be taken care of another 5 times. Means I will train 25 models for each target variable. And for tuning the hyperparameters, I basically used Bayesian search CB as the data set is very less. I mean, the number of records are low. That's why I chose Bayesian search CB, as it takes different folds into account for tuning the model parameters. And if I wanted to estimate the model performance on the unseen data, as you can see, the model was able to perform better for the respiratory allergy types, but not that better for the food allergy types. I will speak more about this, why is this the case, in the coming slides, where I'll share insights about my findings regarding the dataset. And the one the major issue I would say, like, it would help if it is addressed for the future project, is the chip type that is used to measure the allergens. I mean, if you take the Alex chip type, there are 18 missing allergen values. I mean, the chip type is not able to measure these values, these allergen types, which are present in the test set. I mean, and if the patient allergen proteins were measured by ISAC V1 or V2, and there are 206 allergen protein values which are missing. I mean, we don't have any idea about how or what the effect on the patients if they are measured by ISAC V1 or V2 out of 318 protein values. So, I mean, around 70% of the rows measured by the ISAC chips, they are missing. We don't have any idea about how the proteins reacted with respect to environmental factors. This would address the issue of most of the performance issue which I shared earlier. And another important factor is like information about treatment type is very important for all the target variables. And I tried looking at different target variable feature importances and found that treatment type, whether a patient has gone different treatment types, help. I mean, it's an important feature across different target variables. And I would think like demographic information, where the patient look. I mean, it would have its problems, but demographic information could help the model to better predict. And I took throughout the competition, I took so many references, and I'll be sharing most important ones. These are the references I used throughout the competition to better understand the data and learn how the data is collected and how I can acquire the real world information about biomedical data and better perform well in the competition. So these are the references I used, and now I'm open to questions that you may have or general discussion that you may want to share with me.
Thank you.
Yeah.
Thank you very much, Rakesh. I'm Joanna Witt. So first of all, I'd like to congratulate you because indeed the presentation of your way of addressing this challenge was really very interesting for us, even I would say as soon as Naama back from Trusty gave us access to the complete files, we were, I would say, in awe while reading your presentation and explanation. Second, I have a very naive question. Please don't laugh at me. But you talked about a specific one model for each allergen and
yes,
about making a chain. Would such a chain allow learning for one model from the others?
I mean, the chain classifier, if you look at the targets, there is a certain structure in the targets themselves. Like if none of the allergy present rows for respiratory and food and venom type of allergy is 0, false, then allergy present would be automatically false. So there is a certain structure in the target variables themselves. And in my opinion, like a chain classifier it did not perform well compared to separate models. That's why I chose separate model for each target variable.
Okay, thank you.
Yeah.
And my second question is more, I would say, technical. So you noticed the heterogeneity in the origin of data between the two chips, allergen chips that we had used in the laboratories.
Yeah.
That's because Isaac was the original one that we had been using since 2008. And Alex is a more recent one that that became available around 2018 or 19. When you looked at those data, did you notice differences between results, IgE results obtained with one or another of those allergen chips?
Okay, let me explain using this slide. So imagine these are rows and these are allergen proteins that we generally measure. And for this row, if you take which is measured by Alex chip type, then most allergen proteins will be available for us to make this decision. And imagine for this chip type Isaac V1, if the proteins which are not measured by this are the proteins which we use to judge whether the patient has food type of allergy or not. We don't have any information about the patient. Information about the proteins which result in food type of allergy. Then how we can make the judgment? Like, it would be impossible, right?
Yeah, this I understand. But my question would be, so if, let's say that instead of allergens, these were like nucleotides. Supposing there is the same allergen here, let's say ACT D1 here with Alex and ACT D1 here with Isaac V1. Did you notice any difference between the same allergen analyzed with the two allergen chips?
No performance difference. My concern is if we are missing out majority of the allergen proteins which judge the presence of certain type of allergy, then it would be a problematic, right? You can't make judgment with missing values.
Okay. Thank you very much, Rakesh.
That's what my point is.
Thank you.
We have another question.
Hi, thank you very much, Rakesh, for your amazing job on the domain. I wanted to acknowledge that it was very interesting for us because you really tried to understand why and how we are working, and you went to the website in order to see each molecules and each protein what it was, and it's very interesting for us, even if
it was very time consuming.
You won for that. You won for that. And my question is about food allergy. And you mentioned, and it's what we saw when analyzing your result, food allergy is well less predicted. And for you, is that only the fact that the data set is very well imbalanced, and in particular for food allergies?
Yeah, I would say like the data is very imbalanced for this type of food type allergy. Like there are hardly any positive examples to support to learn whether a person has a food allergy or not. I mean, adding positive examples for this type of allergies would help the model. Imbalance is the main issue, I think, here, and missing values of the allergen proteins. If you address these two problems, then we can make even better model.
Yes, but yes, and if it wasn't just the imbalance part, was a kind of chip that would help to improve the result for food allergy prediction? Yeah,
that's correct. Chip type also has some effect, I think, because majority of the allergen proteins are missing when we measure the patient allergen proteins using Isaac V1 or V2, because 206 allergen proteins are missing out of 318. So what judgment could you make given the wide range of targets we need to predict?
Thank you very much.
Yeah. Thank you.
Do we have other question? No. Okay. We don't have any question online as well. So thank you, Rakesh, and congratulations again.
Thank you very much. Thank you, everyone.
So for the last talk of the day, we are going to switch back to French. So if you need the handset. Donc merci à tous les intervenants et notamment aux lauréats qui se sont présentés pour nous d'introduire leur approche. C'était très enrichissant et très intéressant. Donc on va clôturer cet événement avec Lauriane Armand, donc, qui est chef de projet Data Challenge au Health Data Hub et qui va présenter l'initiative Data Challenge en termes d'ouverture.
Merci beaucoup Laurie et merci à tous d'être présents à l'occasion de cette journée autour de l'IA et de l'allergologie. C'était vraiment un plaisir de vous avoir tous et un plaisir d'accueillir également un des lauréats. C'est grâce à ce genre d'événement qu'on peut voir l'impact de nos projets au Health Data Hub et plus particulièrement de nos projets Data Challenge. Alors, donc, comme l'a dit Laurie, donc moi je fais partie du Health Data Hub depuis à peu près 2 ans en tant que chef de projet Data Challenge et Laurie et moi notamment on s'occupe de l'organisation et de l'accompagnement de projets Data Challenge. Alors, donc on va faire un focus sur ce fameux programme Data Challenge du Health Data Hub, mais avant ça, je vais faire un petit retour sur le Health Data Hub en général, parce que peut-être que tout le monde ne nous connaît pas. Donc le Health Data Hub, c'est un groupement d'intérêt public qui a été créé en 2019 et qui a pour but de faciliter l'accès à la base principale, notamment du SNDS, le Système national des données de santé, et qui est donc le guichet unique d'accès à ces données-là, et également à d'autres données qui font partie du catalogue. Donc voilà, le but en fait, c'est de valoriser les données de santé en France et de valoriser leur réutilisation à travers des projets d'intérêt public. Donc le Health Data Hub a aussi une plateforme technologique à l'état de l'art. Donc c'est une plateforme avec plusieurs outils qui permettent de réutiliser ces données-là grâce à plusieurs outils et bibliothèques disponibles. Et c'est aussi un groupement d'intérêt public qui va fédérer toutes les interactions de l'écosystème de la donnée de santé, donc pour essayer de rassembler les différents acteurs de toutes spécialités et voilà, industriels, hôpitaux, médecins, essayer de créer une véritable communauté autour de la donnée de santé. Alors plus particulièrement, donc, parmi ces missions, il y a aussi une mission parallèle du Health Data Hub qui est la mission d'animation de l'écosystème. Et un des leviers pour animer l'écosystème, c'est l'initiative Data Challenge en santé. Donc ça fait partie des initiatives qui ont pour but de promouvoir l'innovation et la réutilisation de données de santé. Et cette initiative, elle est menée en partenariat avec, donc dans le cadre du plan France 2030, avec la délégation ministérielle au numérique en santé et un financement qui est opéré par BPI France. Donc voilà, avec ces acteurs-là, on finance et on accompagne des projets Data Challenge qui font partie du programme Grand Défi. Alors, un peu plus particulièrement, l'objet du Health Data Hub dans l'accompagnement de ces projets Data Challenge, comment ça fonctionne? En fait, on va réaliser des appels à projets. Donc, en 2021, notamment, la Société française d'Allergologie avait répondu à cet appel à projets, qui sont destinés donc, aux acteurs de l'écosystème. Donc, ça peut être des sociétés savantes, des hôpitaux, des établissements de santé voilà, publics ou privés, des groupements de coopération sanitaire et des IHU qui vont venir à notre rencontre, voilà, répondre à cet appel à projet avec une problématique médicale à laquelle on peut répondre à l'aide de l'analyse de données de santé. Donc nous, on va sélectionner des projets par ce biais et ensuite on a donc un financement de la part, enfin, qui est opéré par la BPI France, la Banque publique d'investissement. Et ensuite, le HDH va apporter un accompagnement et un soutien de 18 mois pour l'organisation de ces projets Data Challenge. Donc ça va partir de la définition et du cadrage du projet. Donc ça va être à la fois sur le plan scientifique, technique et aussi réglementaire, parce que comme on est sur de la donnée de santé, toutes les problématiques d'anonymisation, tout le cadrage, est-ce qu'on va devoir avoir une autorisation CNIL, est-ce qu'on peut passer par des méthodologies de référence, voilà, donc ça on a des équipes juridiques qui aident à la structuration du projet et des équipes techniques aussi dans notre équipe data qui aident à formaliser la problématique médicale pour en faire une problématique qui puisse être résolue par une approche de machine learning. Donc après avoir cadré, avoir aidé au cadrage du projet, on accompagne aussi dans la phase de collecte des données. Donc en fonction des projets, parfois on a des porteurs de projets qui arrivent avec des bases de données préexistantes. Donc à ce moment-là, il y a un peu moins de travail pour nous, mais parfois on a des projets qui veulent voilà, conduire à des études multicentriques et on va devoir les accompagner pour conventionner avec les différents centres fournisseurs de données, voilà, aider à l'information, au recueil de non-opposition, voilà, toute l'information des patients. Et on peut aider aussi à l'anonymisation des bases de données, voilà, parce que comme les données sont ouvertes dans un premier temps dans le cadre du challenge et ensuite sont vouées à être mises en open data, on doit s'assurer du parfait anonymat de ces données-là, voilà, pour respecter voilà, le RGPD. Et ça, du coup, on aide à la fois sur le plan réglementaire, aussi sur le plan technique, parce qu'on a développé des infrastructures et des plateformes sécurisées pour pouvoir traiter et anonymiser, si besoin, ces données-là avant de les transmettre à la plateforme qui héberge le challenge. Donc ensuite, voilà, il y a un autre support technique qui va, voilà, ça va dans le même sens pour la collecte des données. On peut fournir aussi des serveurs, donc voilà, des espaces techniques en fait pour récolter les données, parce qu'on a d'autres projets de Data Challenge qui utilisent notamment des données d'anatomopathologie, qui sont des données très lourdes. On a des bases de données qui font plusieurs téras, voilà. Et enfin, on accompagne aussi sur la communication, parce que donc une fois que tout ce cadrage, cette collecte de données a été effectué, on va lancer le challenge. Donc c'est bien beau de faire un data challenge et de concevoir tout ça, mais il faut derrière qu'il y ait des participants, qu'il y ait voilà, de la communication autour de ça. Donc on a à la fois les plateformes qui font un beau travail pour recruter des compétiteurs, mais le Health Data Hub participe à cette communication-là. Et on valorise aussi tous les résultats qui sont issus des Data Challenge, donc en participant à des rédactions d'articles scientifiques et de vulgarisation aussi, pour que ça puisse parler aux citoyens et un public voilà, qui n'est pas forcément acculturé à la problématique médicale. Et on participe aussi, on accompagne les porteurs de projets dans l'ouverture des résultats, parce que ce qui est important, c'est que voilà, pourquoi est-ce que le Health Data Hub participe et organise de telles compétitions en sciences des données? C'est aussi dans une démarche d'intelligence collective. Donc déjà, le Data Challenge en lui-même, ça permet d'avoir des citoyens, des industriels, n'importe qui en fait, qui peut participer au challenge et essayer de résoudre une problématique médicale. Mais aussi, l'objectif, c'est après de continuer à valoriser la base de données qui a été créée pendant cette phase de conception du challenge, en l'ouvrant en open data, pour que ces données puissent continuer à profiter à l'ensemble de la communauté et être voilà, réutilisées, valorisées. Et on encourage aussi également la mise en open source des algorithmes qui ont été produits à l'occasion des Data Challenge. Donc voilà, par exemple, tous les lauréats aujourd'hui qui ont fait leur présentation, voilà, leurs algorithmes sont disponibles sur la plateforme de Trust.io. Donc voilà pour l'accompagnement du Health Data Hub dans le cadre de ces Data Challenge. Alors là, juste un petit focus sur un des derniers supports d'information qu'on a pu produire au HDH. Donc à ce jour, j'en parlerai un peu plus tard, mais on a accompagné, ou on est en train d'accompagner un total d'une dizaine de projets Data Challenge en santé. Et grâce à cette expérience, on a voulu voilà, mutualiser tout ce qu'on a appris en fait en accompagnant ces projets innovants, parce que voilà, chaque nouveau projet a ses spécificités, et on a essayé de combiner ça dans une formation en ligne, donc un MOOC de 45 minutes qui est destiné donc à tout porteur de projet potentiel ou tout membre d'une équipe projet qui va se lancer dans l'organisation d'un data challenge. Voilà, c'est une formation interactive qui recense un peu toutes les bonnes pratiques à connaître et à appliquer pour organiser un data challenge en santé. Donc voilà, toutes les spécificités des data challenges liées à l'analyse de données de santé. Donc vous avez un QR code que vous pouvez scanner si vous souhaitez accéder au MOOC, et sinon il est disponible sur le site internet du HDH. Alors là, on a mis un historique en fait de l'initiative Data Challenge pour reprendre un petit peu le fil de l'histoire. Donc ça a commencé avec un premier Data Challenge en 2020 qui a été porté par la Société française de pathologie, donc le Data Challenge TissueNet, qui portait sur la détection des lésions cancéreuses et précancéreuses du col de l'utérus. Donc c'était sur l'analyse de données d'anatomocytopathologie, donc des biopsies du col de l'utérus. Et c'est suite au succès de ce premier Data Challenge qu'on a décidé d'industrialiser la démarche et de lancer un premier appel à projet en 2021. Donc voilà, appel à projet auquel la Société française d'Allergologie a participé. Et on a sélectionné donc 6 projets sur des thèmes médicaux variés et avec voilà, différents acteurs. Donc on a commencé à accompagner ces projets-là, et en parallèle, en 2022, on a relancé une nouvelle vague d'appels à projets pour sélectionner 3 nouveaux projets. Et en 2023, donc on a commencé à lancer les premiers challenges, les premières compétitions donc issues de l'appel à projet 2021. Donc on a la Société française de pathologie et de dermatologie qui a terminé donc le Data Challenge Visiomel, qui était un challenge sur des lames anapathes qui portait sur le mélanome et la récidive à 5 ans. On a donc le Data Challenge de la Société française d'Allergologie, l'Allergen Chip Challenge, qui a aussi eu lieu un petit peu après. Et enfin, le Data Challenge Dianodan des hôpitaux universitaires de Strasbourg, qui portait sur les maladies rares à expression orale et dentaire. Donc là, on avait des images, des photographies et des radiographies de la cavité buccale en support de ce challenge-là. Et enfin, donc en fin d'année ou en début d'année prochaine, on va lancer 2 autres challenges. Donc un avec la Société française de médecine nucléaire qui va porter sur des scans cérébraux. Et le but, ça va être de développer un algorithme capable d'aider au diagnostic du syndrome parkinsonien. Donc on est sur de l'imagerie. Et avec l'hôpital Foch, le Data Challenge DigiLut, qui va porter sur la détection du rejet de greffe pulmonaire. Et encore une fois, ce sera un challenge sur des données d'anapath. Et en 2024, donc là, c'est les challenges de la vague d'appel à projet 2022, on a le groupement francophone d'hématologie cellulaire et la société Algoscope qui, en partenariat, organise le Data Challenge Cytologia, qui va porter sur la classification automatique des leucocytes, donc pour optimiser la lecture des frottis sanguins. Et l'IHU ICANN, où il y a 2 équipes qui viennent de cette IHU qui proposent 2 challenges différents. On a le challenge cardiaque qui porte sur des cardiomyopathies héréditaires et le challenge Anitia qui porte sur la prédiction des risques chez des patients qui ont une maladie du foie. Donc voilà, ça va être sur des données tabulaires aussi cette fois. Il n'y aura pas d'imagerie dans celui-là normalement, donc voilà, c'est un autre challenge avec celui de la SFA où on n'a pas d'imagerie, donc un challenge assez intéressant aussi. Donc voilà pour l'historique de l'initiative Data Challenge. Et donc, en 2023, encore une fois, on a décidé de renouveler l'expérience et de relancer l'appel à projet Data Challenge. Donc là, voilà, je vais m'adresser à tout participant susceptible de pouvoir organiser un Data Challenge en santé. Donc, vous pouvez retrouver sur le site de BPI France toutes les informations sur les structures éligibles. Mais voilà, globalement, vous pouvez nous contacter directement aussi pour qu'on organise avec vous un échange voilà, autour de vos projets, parce qu'on reste assez flexible sur les projets qu'on accepte, parce que voilà, on essaie d'adresser un maximum de spécialités, et les Data Challenge, ça permet quand même d'adresser aussi beaucoup de problématiques, donc c'est quelque chose d'assez large, c'est dur de restreindre ça dans un cahier des charges. Donc l'appel à projet est actuellement ouvert. Il est ouvert jusqu'en 2025. Cette fois, on va faire plusieurs vagues de relève plutôt que d'ouvrir et de clôturer comme on l'a fait auparavant. Là, il est ouvert en continu et on va avoir une prochaine vague de relève en fin février 2024 de l'année prochaine. Donc voilà, si vous souhaitez candidater, vous pouvez déposer directement un dossier sur la plateforme de BPI France. Et concernant donc les critères pour participer à l'appel à projet, il faut déjà être une structure éligible, faut avoir une problématique qui a un intérêt clinique et surtout qui puisse être résolue par de l'analyse de données, que les données soient en quantité et une volumétrie suffisante voilà, pour permettre des approches de machine learning, et également qu'il soit possible de les rendre anonymes, puisque comme on doit ouvrir les données à l'ensemble des challengers, puis en open data, voilà, c'est important d'avoir des données qu'on puisse anonymiser. Et voilà, donc je vous laisse vous rendre sur le site de BPI France si vous êtes intéressé. N'hésitez pas aussi à nous contacter par mail si besoin. Voilà, et vous avez également, donc là on a le mail si vous avez besoin de nous contacter à ce sujet, et ici un petit QR code si vous voulez rester informé sur toutes les nouveautés autour des Data Challenge. Donc ça s'adresse d'une part aux porteurs de projets éventuels qui sont intéressés par l'initiative Data Challenge, mais aussi, s'il y en a parmi vous ou en ligne, aux potentiels challengers, puisque c'est via ces newsletters et ces communications-là qu'on communique sur l'ouverture de tous nos challenges. Donc voilà, si vous voulez être les premiers au courant pour participer au futur Data Challenge accompagné par le Health Data Hub, voilà, vous pouvez scanner le QR code. Eh bien, je pense que c'est tout pour moi. Merci beaucoup, merci à tous. C'était vraiment un plaisir de vous avoir aujourd'hui. Et Johanna, si vous voulez avoir le mot de la fin, je vois lever la main. Ah, oui, si vous avez des questions, excusez-moi. Il n'a pas entendu.
Oui, merci beaucoup Lauriane. Merci beaucoup pour votre accompagnement pendant tout ce projet. Et aussi merci à Agathe qui n'est pas avec nous. Donc je vois qu'elle a été avec sa petite Johanna aujourd'hui. Elle a préféré la petite Johanna à l'assemblée d'aujourd'hui. C'est vrai que je me suis posé la question. Et non, j'avais deux questions. Donc d'abord, est-ce que ce type d'appel à projet serait ouvert, par exemple, à la candidature monocentrique d'un CHU?
Oui. Oui, tout à fait, les CHU sont éligibles.
Et deuxième question, du coup, on est dans la configuration où on ne fait pas une lettre d'intention, on ne répond pas à un appel à manifestation d'intérêt, on répond directement avec le dossier complet sur le site de la BPI, c'est ça?
C'est ça. Là, c'est bien un appel à projet. En 2021, c'était un AMI, effectivement, et là, on a changé, on a directement un AAP.
C'est plus complexe, oui. C'est assez dissuasif. Oui.
Après, nous, on vous accompagne. Nous, il n'y a pas de souci pour vous accompagner. Enfin, on a essayé de faire En fait, on a fait un dossier de candidature sur les aspects scientifiques et techniques, enfin, pour essayer en fait de cadrer un maximum le projet dans cette première phase-là de candidature. Après, sur tout ce qui est annexe financière, on sait que des fois, c'est un peu plus laborieux pour les porteurs de projets. Ça, dans un premier temps, c'est pas grave si c'est pas parfait au moment du dépôt, parce qu'en fait, vous êtes jugé dans un premier temps sur tout ce qui est scientifique. Après, pour tous les aspects financiers, le LSATUB et BPI France vous aident et vous accompagnent à remplir votre annexe financière. On a des formations pour
oui,
ça.
Je modérerai un peu parce que c'est vrai que nous, l'année dernière, quand on a resoumis, on avait quand même sous le coude l'ensemble des acteurs parce qu'on nous demandait quand même des devis pour la protection des données, des devis pour la plateforme, des devis pour je ne sais plus quoi. On les avait sous le coude. Imaginons que quelqu'un part de zéro comme nous, on partait en 2021. L'investissement de dire on va faire tout ce travail que nous, on avait fait entre septembre 2021 et fin janvier 2022, mais en sachant qu'on était quand même sélectionnés, je pense que pour une structure qui part de zéro, c'est difficilement faisable. Hein.
Oui, non, tout à fait. Je vous rejoins là-dessus. Vous n'êtes pas les seuls à nous faire ces retours-là. On est obligé de vous demander ces éléments pour vérifier que tout simplement, le projet rentre dans l'assiette de financement disponible. Après, nous, encore une fois, notre équipe, on se tient à votre disposition pour vous mettre en relation avec les différents prestataires pour avoir rapidement des devis ou des estimations. Parce que voilà, après, c'est pour pouvoir lancer le projet. Si dans les faits, c'est pas tout à fait les mêmes prestataires ou que la facture correspond pas au devis exactement, c'est pas grave, faut juste essayer de rester dans l'assiette de financement. Mais on peut pas sélectionner un projet sans nous assurer que au niveau de votre cadrage financier, vous avez bien quelque chose qui rentre dans l'assiette de financement. Merci beaucoup. Est-ce qu'il y a d'autres questions dans l'Assemblée ou en ligne? Je ne sais pas si on a des questions en ligne. Ok, écoutez. Merci beaucoup, merci à tous. Et puis je vous invite à nous rejoindre quand vous sortez juste à droite. Là, vous avez pris le café. Il y a un petit cocktail et un apéritif convivial. Je suis désolée pour les gens en ligne. Vous n'allez pas pouvoir en profiter, mais voilà, pour tous ceux qui sont sur place. Merci à tous.